Okay, guys, we are just steamrolling through topic 3. We're on step 3-4, where we're constructing functions to model linear relationships. So, kind of word problems, because you model these use model real world situations using this information. So we're going to start it off kind of simple here. We got this dude Eric wants to buy a new mountain bike, costs $250. He's already saved 120. Represent right there, right at week 0, right before he's even started mowing. He's already saved $120, and he plans to save $20 each week from the money he earns from mowing lawns. He thinks he will have enough. He will save enough money after 7 weeks. Talk at your table. Oh man, that makes sense. Sorry, just looking down. Talk at your table. It sounds a little weird. Anyway, so if he's saving $20 a week, right, at the end of week 1, he'll have 140 because he's adding 20 each time that each week goes up, right? So as the weeks go up by 1, he adds $20. He adds $20 here, he gets to 160. He adds $20 here, he gets to 180. So we've got our table completed. So after 3 weeks, he will have saved $180. So let's graph this, right? So after 1 week, actually, 0 weeks, he's got 120. So we'll start right there. That's our y-intercept. Okay. And then 1 and 140, 2 and 160, 3 and 180, right there. And that's all the data we have. But but we can extrapolate from here. Let me just make sure I'm getting this. After 7 weeks, is about right here. He wants to get to about 250. I think that's about right. Let's double check here. Well, okay, let's just graph this and see where we get. Maybe it's not 7 weeks. Okay, well, it's not a perfect line on there, but it's all right. Okay, so he thinks he'll have enough money saved after 7 weeks. So we'll go over to 7 and we'll go up. And that looks like about right. Yeah, he'll have right around $260 at 7 weeks, according to the graph. So yeah, it looks like he's on track to do this. He'll have a little bit more than he needs, actually. Now then, let's kind of answer these questions, right? How can you tell the relationship is a linear function from the table, and how can you tell from the graph? Well, I think it's easier to see from the graph, right? Because it forms a line, right? It is clearly a line, right? And then from the table, we can see that we're adding the same amount each time for our output, for our money saved, our y values, and we're adding the same amount each time for our x, our input, or our time in weeks, right? So same number added right here, same number added right here. That is a constant rate of change, which is a property of a linear function. So from the table, let's see if I can write small enough for this. From the table, we can see a constant rate of change. So that's, a property of a linear function. And then from the graph, we can see that it is a line. So very simple. It is a line. Yeah, I don't know. That's how you tell, right? You have a constant rate of change in your table. Boom, it's a line. You have a line. It's a line. Or a linear function. Sorry, that's how we should be saying it. Okay. Schmoot. I'm going to put a picture on this for the because it's got a little picture. Let me actually show you what it looks like. Sorry about that. This is what it looks like. This is a little blueprint right there. I'm going to put that on the final draft of this. A plan for a skateboard ramp shows that the plywood for the triangular sides of the ramp should be cut such that every 9-inch increase in height is accompanied by a 33-inch increase to the base. What is the height of the skateboard ramp shown? So we have a graph right here, and we kind of got this written out. So an increase in height of 9 inches gives you an increase in the base of 33 inches. So what is the height of the skateboard ramp shown? So we're going up by, it looks like, increments of, gosh, these graphs are terrible. Looks like they're from 22 to 44 is 22 inches. So we're going up in increments of 11, which, hey, man, it'll work out because it'll be on the grid. Gosh. All right, so we'll start at 0, 0. And we have an increase in height of 9, so we'll go up to 9, and then we'll go over to 33, which is right here. And then we add another 33 onto that, and another 9 to get to 18. It gets us to 66 right there. And then the next one would be 99, which would be right here at 27. So that's our line. Just like that. Now that we have this line, we can use this very easily to find the slope, right? So we're going to use the slope to write, let's see, determine the slope. There we go. So now, again, we want to do rise over run. Since it's a positive graph, I like to make my triangle on the top of the line. So the difference between 9 and 18 is 9, and the difference between, looks like 33 and 66 is 33. So we have our slope right there. So what we're going to do is take that 9 and divide by 33, right? Because it's rise over run, right? Which is our slope. So we can actually simplify that by dividing the top and the bottom by 3. That's the only thing that's going to go into both of those numbers. And we end up getting a slope of 3/11. Okay. So that's kind of like when you simplify it down to its most simplified form, that is your slope right there. You have an increase in height of 3 inches, and an increase in the base of this ramp of 11 inches. So now we're going to use the slope to write an equation, sorry, typo, for the function shown in the graph. So the idea here is we're just going to put it together. It's going to be, right, y equals mx plus b. We have a b value of 0, right? So we don't have to worry about that. And we have an m value, a slope of 3/11. So again, right, we're going to take this slope and we're going to plug it into our equation. And it becomes y equals, gosh, too many pens, 3/11 x. And we could say plus 0 if we wanted to, but you don't really need to. In fact, you probably shouldn't. It's going into algebra 1. You don't want to do kind of that amateur move right there. So we have this y equals 3/11 x. That's your equation that we found. And we're going to use that equation to find the height for a base length of 110 inches. And so remember, base length, that's our x values right there. So we have our x, and so we have our x value of 110. We have our equation of y equals 3/11 x. And so we're going to take this 110 and plug it in to that value of x. So we get y equals 3/11 times 110. Real easy way to do this is to just take 3 times 110. Gets you to 330, and you'll divide by 11 to get to 30. So that gives us a y value of 30 inches. So the idea here is that for a skate ramp with a length of, let me show you this picture, which again, put it in here. For a skate ramp with a length of 110 inches, the height of it is going to be that 30 inches that we just found. So, yeah. Okay, write a function from 2 values. So we have a toy factory, right? The cost to manufacture 5 toys is $17.50, right here, and the cost to manufacture 10 toys is $30. So right here, construct a linear function in the form of y equals mx plus b that represents the relationship between the number of toys produced and the cost of producing them. So the idea here is that we are going to use our slope formula right here, okay? So we have our 2 points right here. This is our first point, so it's x1 and y1, and this is our second point, so x2 and y2. So we're going to say y2 minus y1, so 30 minus 1750, divided by x2 of 10 minus x1 of 5, so 10 minus 5. Let's use a calculator, right? 30 minus 1750. gives you 12.5. And we divide by 5. It's 2.5. So we have a slope, another room here, slope of 2.5, right? So use the slope in one set of values for x and y to find the y-intercept. So we're going to use y equals mx plus b. And what we need to find is the y-intercept. So we're going to find this value right here. We already know our slope, and we're going to use one set of values for x and y. So we'll either use this set of values here or this set of values. It does not matter, okay? I'm going to use this set of values because it doesn't have a fraction in it, and it doesn't have a decimal in it, okay? So that's our x, that's our x, that's our y. So when we put this together, right, we're going to start with 30, and we're going to say equals 10, right? And then, no, come on, 30 equals the slope, which is 2.5. And then we say 10, my bad, okay? So, and we're going to say plus b, because that's what we're looking for, okay? So let me kind of right, this is our y value, this is our slope, that's our x value, right? So we're kind of plugging all those three values into this equation, and it eliminates the variables here except for that b, and since we only have one variable, we can solve this, right? So 2.5 times 10 is 25. Plus b, we're going to subtract that 25, and we get a y-intercept of 5, okay? Fairly simple. Just using the information in the problem to find that. So now we're going to write our equation in the form of y equals mx plus b. We know our m value, our slope is 2.5. We know our b value or y-intercept is 5. So we just put it together, 2.5x plus 5. And that represents the relationship between the number of toys produced and the cost associated with producing them. Okay. The graph at the right shows the relationship of the number of pages printed over time from a printer with a set warm-up time before each printing. What function in the form of y equals mx plus b models the relationship? Again, we need slope and y-intercept, right? Those are the two pieces of information we need for most of these problems, okay? Very easy to find y-intercept. It is 1, just like that. And then your slope is going to be rise over run. So we go from 2 to 4, which is 2. And then from 10 to 30, which is 20. Right? So it's a difference, right? 30 minus 10 is 20. So now we have our slope right here. It's going to be rise over run. So it is 2 over 20, right? Which is 1/10. Once we simplify, divide the top and the bottom by 2 to get to 1/10. So yeah, we have our m value, our slope of 1/10. We have 1/10, and we have our b value of 1. So when we put it together, it's going to be y equals 1/10 x plus 1. That is the relationship that models the number of pages printed over time. That's that right there. I'm going to put this in my notebook, which is over here. For me, it's going to be on page 37. This is 3-4. Construct functions to model linear relationships. Ooh, it's a long title. Man, I don't even know if I need to write that title anymore because it's like right at the top there. I should probably just stop doing that. This is just wasted effort, huh, guys? Yeah, come on, Wishart, get it together. Okay. So I'm going to put that in there, and then we'll go to our table of contents real quick. and it's on page 36. Nope, no, 37. That is 3-4. Construct functions to model linear relationships. There you go. Thanks, guys.